All right, so I have a question here. I'm just going to answer question A and C. Then you can try out B and D and see what you're going to come up with. The question says, draw diagram to represent the bonding in each of the following ionic compounds. Okay. So first we are going to draw the diagram which represents potassium fluoride. We know that potassium is a metal, all right, and fluorine is a non-metal. So potassium being a metal is going to lose electrons, and for fluorine being a non-metal is going to gain electrons. And on the other hand, potassium has a mass number of 19, while fluorine has a mass number of 9. So potassium, we know that is in group 1, right? Is in group 1 of the periodic table. And fluorine, we know that is in group 7 of the periodic table. Now, by virtue of potassium being in group 1, it means it's going to lose 1 electron to fluorine, and fluorine is going to accept 1 electron from potassium in order to be stable. The configuration for potassium is 2, 8, 1, like this, while for fluorine is 2, 7. So this electron which is at the end here in the last shell will be lost to fluorine, so that fluorine can also have 8 electrons in the outer shell, and that's what we're going to draw. Let's start. So we have potassium on the middle. Let me just do this. Well, we can just draw the last shells, okay? Just the last shells. If you want, well, we can draw this. So we have the first shell. We have the second shell, okay? And we have the third shell. And deep down we know that 1 electron has been lost. So we are going to do this. Put a positive there to show that it's been lost. Alright, so this is sodium ion. Then fluorine is this. So let me use another color. So use that. And do this. Let's use another color here. Alright, so that is how you do it. Then we know that 1 electron was donated to fluorine, so there will be X. This X is an electron coming from sodium. Alright, which now will give us something like this. Then put a minus there to show that fluorine gained 1 electron. So there was a transfer of an electron. So this is all that you do. You show. It's simple as that. Then we can do the same for C. Like I said, B and D you try out. So we can do the same for for C, which is magnesium fluoride. Now in this case, magnesium is in group 2 of the periodic table, while fluorine is in group 7 of the periodic table. So this 2 which is at here is telling you that you need 2 fluorine atoms. Remember that. Let me do this for you. So magnesium is 20 here. Sorry, it's 12 here, and fluorine we said it's 9. So the configuration for magnesium is actually 2, 8, 2. Fluorine is 2, 7. So magnesium has to lose these 2 electrons. Now, where the challenge is here. Fluorine can only manage to get 1 electron. But where is the other electron coming from magnesium going to go? So we need another fluorine. This is how come we have the 2 here. Are we together? So 1 electron will go to this, or the other one will go to there. And they'll all be stable. Fluorine, magnesium will remain with this, and fluorine is going to have 2,8 here and 2,8 there. So we need to draw this. That's why there is a 2 there. Let's just begin. So starting with magnesium, we have that and we have that. Like I said, I'm just showing those shells that are involved in bonding, like that. So this is the last shell after 2 electrons have been lost. So we're going to put 2 plus here. Reason is simple. So magnesium has lost 2 electrons, like that. Now we need 2 fluorine atoms. That means we are going to have the first one here, and we're going to have the second one. So let me first finish drawing this one. Then we're going to have the second one here. Okay, so now let's plug in. So we have there, we have there, we have there, 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 and there. That's fluorine. This is another fluorine, like that. And you know that magnesium donated 1 electron to each fluorine. Okay, so this is a fluorine ion. Just put it there inside, and this one's a fluorine ion. So this one will be enclosed. It will be enclosed, but you have to show that there's a negative there. Even this one will be enclosed, so that there's a negative. So you can show by the means of an arrow that 1 electron is donated there and 1 electron is donated there. This is what I expect you to do, even for B, as you answer B, as well as you answer D. Thank you so much, PVS Tutor. Don't forget to start your online classes with me, as well as follow us on YouTube, TikTok, and Facebook.